Hey everyone, welcome STEMers to section 4.3. I'm out today, but I want to still make sure that you know exactly what you're doing, so I'm going to make a video of the notes, and we're going to go through it that way. After that, you're going to work through your homeworks for 4.3 and maybe anything you missed from 4.1 or 4.2, and then this weekend you're going to take home a quiz over those three sections. So I want to make sure you know how to do the third section. So here we go. So I am in my note packet, and hopefully you are getting yourself to the same spot. If yesterday you were really not liking doing dividing polynomials by long division, I kind of agree with you. But it is something that we need to know how to do, and so make sure you can do it. What you need to know is that most of the time when we're dividing polynomials, we don't actually use long division. So bad news, you still have to know how to do it. Good news, we won't usually be dividing polynomials that way. We usually do it this way. So this is definitely something you want to get really good at. So here we go. So the problem looks quite a bit like yesterday, doesn't it? We've got two polynomials, and we are dividing them. But instead of setting up something that looks like that and doing the long division, we're going to set it up just a little different. So we are going to make the dividing thing look like that. So make one of those. And what we want to do is we want to divide out one of the solutions of this. This is to the third power. Because it's to the third power, we know that it has two solutions. And we know that this factor here tells us where one of those three solutions are. So if we want to define one of those solutions, we would set this equal to 0, and we'd add 2, x equals 2. So what we want to do is we want to divide that solution out. Moral of the story is, whatever you see right here, take the opposite. Put it right there. So a 2 goes right there. Now, synthetic in general kind of means like a fake copy of something. So we're going to do the division without actually using the x's, because there's no x's in here. I think that's why they call it synthetic. So instead of writing a 5x to the third right here, we're just going to write the number 5. And we got to go in descending order. So after x to the third, the next degree would actually be x squared. And you might be saying to yourself, man, there's nothing that's squared in this polynomial, which means there are 0 things that are squared. And then the next thing, lowest degree, would be the x's. There is -2 of those. And the last would be just the number at the end. So that's -36. So why is it called synthetic? Because normally we would have an x third here, x squared, x here, but we're just not putting them in here. So here we go. How can we use this crazy setup to divide this by that? Step 1, take the 5 and drop it down. Not so bad. This 2 right here, you always use it to multiply things. So this 2, now that we have this 5, we're going to multiply it, and that's going to give us a 10. That's how we get back up here. 10 it is. Once we get to there, we take these two numbers and add them. So 0 and 10 is 10. So we get up by multiplying and down by adding. So 2 times 10 is 20. -2 plus 20 is 18. 18 times 2 is 36. And 36 and -36 is 0. So how would we write our answer? How does this actually help us? Well, it started out as a degree 3 polynomial, but since we divided out one of the solutions, it started out having 3 solutions, but if we divide out one of them, there's only 2 solutions left. So this started out as 5x to the third, but now it's 5 down here. After the 2's been divided out, it's now 5x squared. So in our answer, we're going to say 5x squared. This started out as a squared. Now it's just plus 10x. And this used to be a -2x. which got turned into an 18, and now it's just plus 18. If you wanted, you could do long division, do this problem that way, and you'd end up at the same spot. This would go faster, though, so this is probably how you'll do it most of the time from now on. Let's keep going. I want to divide this synthetically. If this is an x plus 8 right here, that means that the number on the outside is going to be a negative 8. The squared term has 1 of them. The x term has 9 of them. Number at the end is 6. What were our steps? We start by dropping down this number, and then we always multiply to go up and add to go down. So multiply, negative 8, add 1, multiply, negative 8, add negative 2. So this started out as x squared, so now it's just 1x plus 1. So our answer is x plus 1. But wait, there's also this negative 2 here. You remember that when we were doing long division yesterday, sometimes there are remainders left over. This would be an example of one with a remainder. So in the last problem, the last thing was a 0. That means there's no remainder. If there is a non-zero number right here, that means there is a remainder. So we are going to write the remainder just the way we would have if we were doing long division. So it will be minus 2 divided by whatever we're dividing it by. And we were dividing this thing by the factor x plus 8. Do long division, you'd get the same thing. This is just an easier way of doing it. Let's do one more at the bottom. So it says use synthetic division to evaluate the polynomial for the given value. What is the remainder? So basically they're telling us, hey, this is going to be kind of like example 2. It's going to have a remainder. I want you to tell me what that remainder is. So let's do it. All right, so in the other ones, they initially gave us the factor. So we had to convert that by switching the sign of it when we turned it into a solution, here and here. But if you look down here, they right at the start tell us what the solution is. They didn't write it as a factor. They wrote it as a solution. So in this one, we don't have to change the sign. We just write negative 3. So there we go. All right, x to the third, there's 1 of them. X squared, there's 3 of them. X's, there aren't any, so there's 0 of them. And numbers at the end, 4. All right, let's get it going. Drop it. Multiply it. Add it. Multiply it. Add it. Multiply it. Add it. And if you divided it, the polynomial that you get would be x squared plus 0x plus 0 plus a remainder of 4 over whatever. But they didn't ask for that. All they wanted to know is what is the remainder. And so the remainder is 4. So what is the remainder? All right, the remainder is 4. And that's that. At this point, you have what you need to do 4.1, 4.2, and 4.3. So at this point, I'd like you to spend the remainder of class going through these three sections, finishing any homework that you might not have finished, and after that, this weekend you're going to take that quiz home and you're going to do a great job at it, and I'll see you on Monday. Thanks.